Section 3.5, Example 1, Exponential Growth. Here are your objectives for Section 3.5, and in Example 1, you're going to be working on exponential growth. Okay, the exponential growth and decay model, the equation for either growth or decay will be here, either f of t or a equals a sub 0 times e raised to the k times t power. A sub 0 is going to be the original amount you begin with, and a is the amount at time t. Say if they say, 5 hours later or 10 hours later, whatever the case may be. Now, k is a constant, and if k is greater than 0, then it's going to be a growth model, and if k is less than 0, you're working with a decay model. So in example 1, we are posed this problem that in 2000 the population of Africa was 807 million, and by 2011 it had grown to 1,052 million, which means 1,052 million. Use the exponential growth model, in which t is the number of years after 2000, to find the growth function that models the data. Okay, so from 2000 to 2011, and t is the number of years after 2011, so here we go. A is what you end up with after a time period has passed, and in this case that's going to be the 1,052 million, equals the beginning amount, at least in 2000, was 807 million, times e raised to the k times, and time that has passed is 11. So we have 1,052 equals 807e times, raised to the 11k power. Okay, so let's divide both sides by 807, and when you do, you'll get 1,052 over 807 equals e raised to the 11k. Okay, so we have e raised to the 11k equals 1,052 over 807. We want to solve for k. So to do that, we need to take the natural log of both sides. The natural log of e to the 11k equals the natural log of 1,052 over 807. Okay, we need to remember this very valuable property right now. The natural log of e raised to the x power equals x. So the natural log of e raised to the 11k power is 11k. 11k equals the natural log of 1,052 over 807. And so to get k by itself, you divide both sides by 11. And now it's calculator time. So if you take the natural log of the quantity 1,052 over 807 and then divide by 11, you'll get k is about 0.024. Okay, make sure you get that on your calculator. So the model equation is a equals a sub 0 times e to the 0.024 times t power. That's the model equation. Okay, next we're asked by which year will Africa's population reach 2,000 million or 2 billion? Okay, so we know at least what our model equation is, and I have that right here. So we want to know when it will reach 2,000 million equals, and remember the amount in 2000 was 807 times e to the 0.024, because now we know what k is, times t. That's what we're trying to find out. By which year? By what time? So now divide both sides by the 807. We'll have 2,000 over 807 equals e raised to the 0.024 times t power. And hopefully you see now, to isolate the t, first we need to take the natural log of both sides. So the natural log of 2,000 over 807 equals the natural log of e to the 0.024 t power. And remember, the natural log of e to the x equals x. So the natural log of e to the 0.024 t equals 0.024 t. So we have natural log of 2,000 over 807 equals 0.024 t. So now to isolate t, we need to divide both sides by 0.024. And you certainly need your calculator now. I'll give you a moment to run the numbers. And you should get t is about 38. So we'll take about 38 years for the population to reach 2,000 million, which is equal to 2 billion.